A square loop PQRS carrying a current of 6 ampere is placed near a long wire carrying a current of 10 ampere as shown in figure. Let's say this current is I1 given by 10 ampere and the loop carries current I2 where I2 is 6 ampere. We had to show that the magnetic force acting on the part PQ is equal and opposite to that of part RS. Okay, now let's suppose we have the direction of the current in the loop like this. Okay, now clearly due to this long current carrying conductor, the magnetic field at PQ will be varying. It won't be a constant. Let's suppose I do all the stuff of integration and all those things. I calculate B net that is acting on via PQ and let it be something B dash. Okay, now this is my B dash which is acting on the via PQ. Similar will be the magnetic field that will act on RS because PQ and RS are parallel, are of same length, so this will also be the B net on RS. Alright, now we do have a magnetic field, we do have a current, so obviously some force will act on PQ as well as RS. So let's calculate the direction. Alright, the force is given by BIL. Fine, current is same, length is same, and from this equation I can say that magnetic field is also same. So the force that is acting on RS and PQ will be of same magnitude. Let's talk about direction. Okay, now due to this current carrying conductor, the magnetic field will be inside for both of them. Now apply IDL cross B. I have IDL cross B for PQ, so force on PQ is in downward direction and force on RS by IDL cross B is in upward direction. So hence F net due to PQ and RS will be 0 because both the forces are equal in magnitude and opposite. That is the proof for first part. Alright, in second part I have to calculate the magnetic force on the square loop. Fine. Now I have proved you that the force on PQ and RS are equal and opposite, so the resultant for both of them will be 0. Let's talk about the force acting on PS and RQ. Okay, so the force on PS will be first of all due to long current carrying conductor A and due to RQ. Fine. Now we know that the general force is given by BIL, so magnetic field is usually given by mu naught I1 by 2 pi P into I2 into L. Fine. Now using this same very formula for PS, I do have force on PS due to long current carrying conductor, so that will be mu naught I by 2 pi. This will be I1. Alright, I1 is this current. Perpendicular distance is 1 centimeter, that is 0.01. Mu naught I by 2 pi P into I2. I2 is the current in this wire, that is 6. Length of PS is 2 centimeter, that is 0.02. Alright, now magnetic field is inside as we showed. Direction of the force on PS due to this magnetic field is calculated by IDL cross B, so it will be here. Okay, force due to straight wire, and the force due to RQ. Okay, now here it is RQ. I have magnetic field due to RQ is in upward direction at PS. Fine, so I can write it as, let's erase this part. So I do have minus of mu naught into current in RQ, that is 6, divided by 4 pi perpendicular distance between them, that is 0.02 centimeter, into 2 times of sine of phi, that is none other than a by root 2. So let's say I can write it initially as sine phi, that is, let's say I took a middle point over here and join these lines. This is my angle phi. Alright, this is magnetic field into current I into length is again 0.02. Alright, now calculating the value of sin phi, I do have this distance is a by 2 and this distance will be a, so it comes out to be a root c by 2. Hypotenuse is a root c by 2. Alright, so sorry, a root phi by 2. So sin phi comes out to be, alright, in the second part we have to calculate the magnetic force on the square loop. So we'll calculate the force on via PS first. Alright, now the force on this wire will be due to the magnetic field produced by the long current carrying conductor and the wire RQ. So due to the current carrying conductor, the magnetic field will be inside, that is calculated by right hand thumb rule, and due to RQ, the magnetic field at PS is upward. Fine, so the force, I'll calculate the force per unit length acting on PS. So I have mu naught into I1 by 2 pi P. This P is the perpendicular distance between both of them, into current I2. This is the force due to long current carrying conductor on wire PS, and minus because the force due to RQ is opposite to that of the force due to current carrying conductor. So I have mu naught into I2 divided by 2 pi P. Again, P is the perpendicular distance between them, and that is 0.02 meters. Fine. So substituting the values, I have mu naught, that is 4 pi into 10 to the power minus 7 into 2 pi into I1 into I2, that is 10 into 6 divided by 0.01 minus 6 into 6 divided by 0.02. So on solving this equation, I get the force on PS as 8.4 into 10 to the power minus 4 Newton, and the direction is towards right. Similarly, calculating force on RQ, I have mu naught into I1 into I2 by 2 pi P. Now P is this distance minus mu naught I2 into I2 by 2 pi 0.02. So again, just substituting all the values, I have force on RQ as 2.6 into 10 to the power minus 4, and that is again towards right. So the F net is force on PQ plus force on RS, that comes out to be 11 into 10 to the power minus 4 Newton.